Thank you. Welcome, everyone. So yeah, my name is Theo, and I'm a data scientist now, moving to a management at Get Your Guide. And previously, I was also a machine learning engineer at Plista. And what I want to talk about is a software design pattern for data science. And what I want here in this talk is to condensate what I've read and also experienced, and this is a kind of subjective selection of thoughts that I have. And yeah, so that was originally like Will asked me to jump in for these slots. So the talk should be around 20 minutes, and so we hope to have some time for questions. But yeah, I'm sorry I'm not as prepared as I wish I would be. I would like to. So yeah, please bear with me. So with that, let's start with the introduction. We'll define what a design pattern is and what is the focus on this presentation. Then we'll dive into the software design, so more precisely, like what advice we want to give to a data scientist that he should keep in mind when designing software. Then the second thing I want to dive into are more ML designs. And here I want to talk more about choice in the architecture that helps to have cleaner data products or machine learning products. And finally, conclude and open for questions. So what is a design pattern? So a design pattern is a reusable solution to a commonly occurring problem. See, it's not a concrete piece of code that you can just copy and paste from Stack Overflow. What we want is actually what help is actually identifying the pattern will help you first to understand the problem that you're facing, and also help building a common language around this problem. I do not want to focus this talk on pattern, how to improve your model performance. There are already a lot of talks in the wild about how you can improve accuracy and all these kind of things. Here, what I want is pattern that can help you bring your data product, your model into production, and so basically push it through the finish line. OK, let's dive first into our software design pattern. So here, more like lower level advice that I can give. So the first thing that I think is important to keep in mind is that you should design after the fact. So in data science, the work that we do is closely related to research. So there is very high uncertainty around it. So the code that you will write tomorrow depends on the result that you obtain at the end of the day today. And so you should refactor to make it right, but do not try to over-engineer to what you think it will be, because you probably will be wrong. So you should make it right for what it is today. And so you should keep it clean so that you can understand it. And just a reminder, what is refactoring? It's the process of reorganizing the code and changing without changing its external behavior. And as like any software developer, that's part of the normal software lifecycle to refactor the code as it moves forward, basically. And so should keep in mind that this is part of the job, and you will have to refactor your code as you do, but just do it for what is right for now. Then the second thing is you should design for people's cognitive capabilities. So just as a reminder, we know that we estimate that the humans can only hold around 5 elements in memory. So that means that basically when you are writing codes, you should be able to understand the code by only understanding 5 concepts. That means breaking big function into pieces and giving meaningful names so that people do not have to remember what this A, B, I, J, K, etc. means. So the goal is to keep these 5 things to remember, to understand. And so other will struggle, or also you will struggle in the future. You will struggle when you are trying to read your code. It happened to me. I'm sure it already happened to some of you. Then another one is designed for testability, and I think that's the most important one. Most of what we do, even in data science, can be tested. but we need to design it accordingly. What we want in practice is to avoid legacy code. So legacy code, what it is, it's software that we are afraid to modify because it might break in some unexpected way. And I imagine all of you have already experienced this. I don't know if I should touch that or not. Yeah, and test is something that helps us to bring confidence when you want to do any kind of change. And to give you an example in practice, let's imagine an example of a function that was not designed without testability. So we have some pre-processing steps that is doing. Oh wait, can I put the pointer? The laser, yes. So we have a pre-processing step that is doing some function, and actually then, suddenly you need another table, so you just load this table, then you join, and then you continue your magic. Here, it's terrible to test. What makes much more sense is actually to give these things that you need as part of your function, so that if you need to test, you can just pass different type of function instead of having to do some kind of mocking for this table because it's hard coding in the middle of the code. This is an example of how you can basically make your code designed for testability. There are many more things, but I think that's the main thing is like if you ask yourself, how can I test it? That will help you make the code in a much better shape. So yeah. That's the three main software patterns. So first, please refactor your code. This is part of the process, and it's normal to do it. You should break down the code into pieces, and 5 is a kind of rough number you should try to keep in mind, and make it testable so that you can test it. The worst is a piece of code that is not tested. You want to test it, but it's not designed to be testable, so you will need to refactor it before you can test it. But if you refactor it without test, you're already stuck. OK, so with that, let's go into the ML designs. Here, what I want to talk more is about architectural change that you can do to be more effective in your code and to have a cleaner data product at the end. The first thing I want to talk about is this workflow pipeline pattern. So usually a data science project or the data product at the end is composed of multiple steps. We have some pre-processing, we have some training, then we need to deploy, etc. And as the project grows, each step grows and gets more and more complex. And so at some point, you want each of them to be able to work on them independently. It might be not the same time, not the same person, and even not the same team that work on this different part. And so what you need is to have some kind of container, being able to containerize each of these steps and to be able to orchestrate them. See an example on the top of like the different steps that you would expect. So data collection, data validation, pre-processing, building, training, evaluation, and then you deploy the model. And as I said before, you can have different person doing different things. Having this isolation make it more portable and scalable and maintainable. There are some ML-specific tools that helps you, like TensorFlow Extended or MLflow pipeline. But actually, you can also use some tools that are not used specific for machine learning, like Airflow. They are also really great, like more general purpose orchestration tool that can help you do that. And once you have this workflow, actually, then you can integrate it in your CI, or also have some kind of trigger to retrain automatically and things like that. So it helps you to be able to separate them, so that basically you can retrigger some specific steps on some specific events, basically. When, I don't know, if you want maybe to retrain your model once a week, or if the production is getting, or something is changing, then it's good that you have these things already prepared, basically. OK. Then the second one, really useful, is this transform design pattern. The problem here is that the input data usually is not the feature that we will use for the model. So yeah, there is some kind of transformation that needs to happen to the input to be transformed to features, and that needs to happen for the training, but also for the inference. And it easily can happen that we'll end up with having two logics, one that you have for the training and another one for the inference. And of course, if you have two pieces of code doing the same thing, don't repeat yourself, and you increase the chance of having some kind of mismatch. Like the logic can be slightly different, and then you end up to have some weird things happening, basically. And here, this pattern is basically to capture this transformation and keep them and reuse them in both places. And just an example here is you can have a model with an input that have some inputs, let's say the start date, basically. And what you want is to transform this feature into some example, like the feature will be a date of the week or the hour of the day, and you would like to do that. You will need to do that for training and inference. This is the kind of thing where this transform pattern makes a lot of sense. This concept is already present in some of the major library. Like you have it, for example, in PySpark with a transformer. You have it in scikit-learn with this pipeline when you can have the different transform. And TensorFlow Extended also have this concept. Great. Then last but not least, the feature store. So the feature store design pattern. The goal here is to simplify the management and the reuse of the features. And what we want is to decouple the feature creation from the model development. But you should just use it only if and only if the features that are recreated that you need for your model are recreated over and over for different models. And the training and the serving features you already see that they have some inconsistency. And finally, when you have problem productionalizing the features. So basically, in the diagram, I think it will help understand what the feature store. So basically, it's a component that you have between your data sources that you're on one side and the models that can have that want to use these features. And it's basically tailored for ML, which make it easy to get some kind of historical feature values for the training, or just get the latest value that you have when you want to do batch or online inference. There have been quite a lot of hype around this concept, and it should use it wisely in the sense that it can add more complexity than it solves. So you should check with your use case and use it only if it makes sense for you. Great. With that, let's conclude. So yeah, what did today? I wanted to present some useful pattern that we had for data science that I think you should keep in mind when you design your project. There are many more that were not covered in this presentation. And I just made my selection where I think the top one for me was the most useful. Hope you find them useful, but yes. Finally, you might be able to identify some pattern at some point, but decide not to use it. Actually, it's totally fine. Just want to make sure, like, actually just identify this pattern help you to understand the trade-off that you are making if you want to use it or not. So best example will be, again, what we had just before with this feature store. And yeah, I think we're pretty nascent in data science. There's still not so much gathered experience that we have as a whole. So this pattern are likely to evolve, and with the industry as we evolve. So yeah, exciting time to see it happening. With that, that's the end of my talk. Thank you very much. And yeah, opening for questions. I also put some references where these things are coming from, and I will share the slide in the channel so that you can also check this. Most of this actually is coming from this excellent book, Machine Learning Design Pattern, but there are also some blog posts that you can read that are coming from. Yeah.
Okay, well, thanks, Theo. I'm not seeing any questions so far in the Slido, so getting quick.
Yeah. Yeah, can you?
As meaningful names go, I usually have the problem that my names of my columns explode and then you can't see anything anymore. Do you have a golden rule for balancing that one?
First thing, you have, usually you have 80 characters for things, and then you have those 4 things characters. But still, like if your name is more like than 60 characters, it's something. That's pretty impressive. Very expressive. But then usually naming things is one of the hardest things in computer science. And yeah, we're writing software in data science, and so we have the same problem. But usually when it happens, the best thing is actually to ask a colleague. And usually the colleague or like ask you, well, what is it really doing? And usually you can shrink it. And I now do not ask that much my colleague. I just ask myself, like, explain what this is doing. And usually I come up with a shorter name. And there are some kind of recurrent shorten that you can use, like with respect to, you can just do WRT and these kind of things that you can use that are repeated over and over. So yeah, that's my common tip. But in doubt, I will prefer a longer name that explode than having a too short name that no one understands.
Thanks. I've just realized that I was meant to be approving Slido questions, which is why there's probably none in the chat. Anyone, while I work out how to fix that, we've got time for me to fix that, but does anyone have a question they want to ask over the microphone? Yeah, maybe. Cool, yeah, you're convenient.
Hi. I'm not so much in this field, but I was wondering if you consider the, the classic object-oriented design patterns that were described in the Gang of Four book that maybe a lot of people are familiar. How relevant are those kinds of design patterns for data science and machine learning, in your opinion?
I think they are relevant. I think that's things that come on top of those more than things. And what I was thinking about the software one, I think they are the most basic one. So for example, should you use object and things like that? Yes, it makes sense. But sometimes you can have clean code with just some functions that if they are well designed and you have a meaningful name, it makes more sense to keep it easy. And not every data scientist or maybe a data analyst that will understand the intricate of some complex pattern with some object-oriented. So I think they are relevant. I still think that we have to adapt to the audience that we have. And not everyone has a computer science background in data science, basically.
Thanks.
Okay, so found some questions. So there's a number of questions about testing and how much you test. So like, given, you're going to refactor and I'm paraphrasing here, but given you're going to refactor, how do you make the decision between writing tests now and given that they're going to be potentially obsolete in the future?
Okay, so should you write a test if the test will be obsolete soon, basically? So I think testing is important. You should have testing. We ended up not testing that much, like with unit tests in our pipeline, but then I will come you to the talk that I have in the afternoon where I will explain how we do testing in data science for the MLOps in practice, the talk of the afternoon. The high level is sometimes unit tests make sense. For data science, most of the time, I think end-to-end tests make more sense. And there we use some real data to do them. The thing is, I think you should test what you care for the most. Like if you care that you're, I don't know, that you are right on your revenue that you generate or the prediction of revenue, and you want to make sure that it cannot be negative or things like that. That sounds a pretty good use case. Like that very specific edge case, if someone put really weird things on the on-model input, will that give back some slightly wrong results? Probably it's not worth a test, basically. So it should be pragmatic when you test.
Cool. Okay, so the top-rated question is, it's hard to prioritize refactoring over working on new features. Any take on that?
Can you repeat, please?
It's hard to prioritize refactoring over working on new features. Any take on that?
Yes, it's hard. What worked well in the Get Your Guide, what we have done, and I think it can be introduced, is basically you plan in advance days where you will focus on this tech debt and adding tests and things like that, and you say, like, you can talk with your PM, your manager, say, like, in the team, we want to have these 2 or 3 days where we'll tackle the most pressing tech debt things that we have. And it will be in 1 month and things like that. And then on these days, you will only be able to focus on this topic. And that's the best way we found to be able to tackle this. I know that if you follow the normal DevOps, they say that every sprint, you should be adding some 10 to 15, or sorry, 20% of your time to work on this. But it did not work well for us. We always end up spending most of our time on the project and never on this ticket that went pushback. So, but this thing of like, we blocked days, and these days are not for project time, they are for tech debt, testing and things like that. And of course, the other things is, once it happened, it's too late, but at least you can make sure it won't happen again. So once you have an incident and something really wrong happened, usually people are much more comprehensive why you want to add a test to make sure it won't happen again.
Yeah. Okay, so the next top question is, do you have any tips on how to organize the code, like your code base, based on these design patterns?
Oof. No, it depends on the project, the size of the project. I think like if you just have some scripts, then probably you should introduce some function. If you have a lot of functions, probably you should introduce some classes. Probably some repetition that happen. So I think the project will evolve with time. I think there are some great templates with cookie cutter that you can use to how you want to organize between the test and the project and things like that. I would say please keep the bare minimum. Like first, put it in a repository. That would be the first thing, and please put the test in another repository, then in another folder than the thing that you have, your code. Make some documentation. So have something for README that people can understand. But then as it evolves, I think it does not make sense to, I will refer back to the first, like, design for what you have now. Even if you think that this project will be an amazing thing and it will have 1,000 lines of code, but right now it's just 100, just write the code that is, like, make the repository work for her 100th line of code things, not have 20 repository with everything, just 10 lines of codes, because you expect that to be expanded. Just refactor as you go and make it right for what it is now.
Cool. Next question is, are those real software design patterns or best practice from Get Your Guide? And then, no offense, I like them a lot and follow similar rules, is what the person said. But basically, are these actual design patterns that you're using in your work? It was really the question.
Yes. Yes and no. I mean, like, they are coming from my personal experience, so I do not represent Get Your Guide in this presentation. But yes, so for example, we have a feature store that we are experimenting with. we also try to keep the code like, I will not say we're perfect. Actually, this presentation started as an internal one. We say, hey, this is where we should be going internally in our data product team. And where I think we need to improve. So yeah, we're working on it.
Okay, cool. So the next two questions are both about feature stores, so I'm just going to kind of merge them together. Well, one's just a longer version of the other. So can you elaborate a bit more about feature stores, and then maybe some experiences, and how they look like? Yeah, they're quite popular at the moment. So can you dig into feature stores?
I mean, I also had watched you use a feature store, and there is also some nice diagram here, but can I make it a bit bigger? Basically, is when should you use a feature store or not. Basically, that was also coming from this blog post. I think the most important things is like feature store can be really helpful to you if it ticks the right boxes. This is like you have features that you repeat over and over. You have struggled to productionizing them, and you have problems. I think Morena, I see in the audience here, did a talk on feature store on the PyData meetup some time ago, and yeah, they are a big beast basically. So use them if you have a big problem. That will be my main point, and they are made for machine learning, and that can solve a big problem. So which you can have, which makes sure that you have the training. So I think I will refer to this one, that when you train, you are sure to have the right data for the right timing point. Like you always have this problem of leakage, data leakage, basically, where you can, for example, if you train a model, and you look at what are the booking each customers did before to try to predict, you have to make sure that the booking you try to predict is not in the feature of the user when you look at to some aggregation on this. And this is tricky to do. And feature store can help you solve this kind of problem very easily. But you should have this problem, basically. And also make sure to have always the last value when you do online inference, basically.
Okay, so I think you've also answered one of the other questions, which was what are the disadvantages?
Okay.
So you've got nothing more to add on that, cool. We've got time for maybe one more quick question. What are the advantages and disadvantages of using tools like MLflow over building the pipelines manually, for example, using Kubernetes job or Jenkins or whatever, right? Like what are the advantages and disadvantages of using tools like MLflow over building pipelines manually?
Less you build, less you have to maintain. Don't forget that. And the nice thing with this tools is that people, like a lot of people are working to improve them. So it's just like I introduced that, and as we move forward, things are getting better basically. Whereas if you do it yourself, well, everything you build you have to maintain, and if you don't touch it, it will not get better basically. So I think that's the main trade-off, and we are at Get Your Guide, we're really biased toward open source because we think it's really great to be able to reuse these tools when they make sense. Not sometimes you have to build it because we cannot find a tool that solves this problem, and then we build it. But most of the time, there are tools that exist, and then we can help contribute, basically. Or if we don't, then we have a specific problem, then we make a tool, and then we open source it.
Awesome. Well, that's us. That's time. So I think another round of applause for Theo.